This is incredible. 7 planets. 7 planets, all packed within a space smaller than Mercury's orbit. It is like the innermost circle of our solar system, but it is filled with 7 Earths. Normally, that distance should be scorching and destructive. Life should not be possible at all. But what is truly astonishing is that among these 7 planets, several happen to fall right within the habitable zone. That is the region where the temperature is just right, and not too hot, not too cold, so water could exist in liquid form. And among them, one planet is especially remarkable. Its position is exactly at the critical point, neither too close nor too far. There might still be enough atmosphere to shield against the early, high-energy storms from the star. All of this seems almost as if it were designed. This system is named TRAPPIST-1, but is more than just a group of rocky planets. It very likely stands right on the edge of humanity's ultimate question. If there really is life out there, can we still say that we are the only beings in the universe? This star system is arguably the most astonishing and fascinating planetary system humans have discovered in decades. It is about 40 light-years away from Earth, orbiting a star known as a red dwarf. It is very small in size. Its temperature is also very low. Its brightness is even dimmer than an ordinary light bulb. Normally speaking, at such a close distance, it should have been scorched to a crisp long ago. But because this red dwarf releases so little energy itself, instead, these 7 planets are in a strange state of balance. They are very close to the star, not necessarily too hot. Looking at it another way, this kind of structure actually allows 3 of these planets to fall right into the habitable zone. That is, the region where liquid water might exist. These 3 planets have been specially marked by scientists. One of them may have a stable atmosphere. It could survive the wild and turbulent youth. Its star, when radiation is rampant, and that is also why scientists are paying special attention to this system. What is even more astonishing is the age of this galaxy is estimated to be over 7.6 billion years. That is much earlier than our solar system. This means if life really exists here, then long before the first drop of seawater appeared on Earth, it might have already quietly taken root. But the most intriguing thing about this system, it is not just these possible coincidences of life. An even deeper mystery comes from its structure. The distances between these 7 planets are extremely close. This causes very strong gravitational interactions between them. It is like 7 bowling balls pulling on each other. Even the slightest change in force will ripple through the entire system. Scientists have observed their orbital periods. They actually formed a kind of resonance pattern. There is a certain complex but stable rhythm between them. This gravitational resonance can help us infer their mass and density. Results show they are more like rocky planets rather than giants. If these planets are indeed rocky worlds similar to Earth, then whether they can retain their atmospheres becomes a key question. According to current observations, there is evidence suggesting that one of these planets may have retained a so-called secondary atmosphere. In other words, even if its original atmosphere was completely stripped away by stellar storms, it is still possible for it to re-establish a stable atmospheric system. To find out whether these planets actually have atmospheres, scientists have launched the most powerful astronomical instruments humanity has today. From the Hubble telescope to the James Webb telescope are almost all being deployed. The Hubble telescope was the first to take action by observing starlight and the changes in its spectrum as it passes through a planet's atmosphere. It determines whether these planets have thick atmospheres. The results show that at least 2 planets close to the star do not have thick, Neptune-like hydrogen-rich atmospheres. They are either bare rocks or have more deadly, Earth-like atmospheres. But what really reveals the details is the James Webb telescope. The James Webb telescope, it is specifically designed to observe infrared signals. It can precisely detect signs of water vapor and carbon dioxide, and even oxygen. Its sensitivity far surpasses that of Hubble. It can even detect the thermal radiation of a planet itself when the planet is blocked by its star. The Webb telescope focused on one of the planets close to its star. Detailed observations were made. The result was straightforward. This planet has no heat distribution. In other words, it does not have an atmosphere to help transfer heat from day to night. It is like a bare rock exposed in space, with one side being scorched, frozen on one side. These findings gradually ruled out the possibility of the planets closest to the star having an atmosphere, and made scientists shift their focus entirely to the planet that lies within the habitable zone, at just the right distance. And the next question naturally followed. How did a planet like this manage to hold on to its atmosphere under the intense pull of its star? What path did its geological activity and atmospheric evolution take? What journey did it go through? And are we really just 40 light-years away from another Earth? Scientists are well aware surviving in a galaxy like that is not easy, especially when facing an extremely volatile star. During the first few 100 million years after its birth, this red dwarf went through a period of intense eruptions. It constantly emitted high-energy radiation, ultraviolet rays, X-rays, and charged particles like a high-powered laser cannon that never stops firing, relentlessly bombarding every planet nearby. During this period, for any planet that got too close, it was almost a catastrophe. Their atmospheres were stripped away layer by layer. Hydrogen escaped first, followed by heavier molecules like water vapor and carbon dioxide. It still could not escape disaster. Scientists call this process hydrodynamic escape. Simply put, the atmosphere was completely blown away. That so-called star of hope we just mentioned, the one that is at just the right distance in the habitable zone, the one that looks most like Earth. How did it survive? Research shows his luck might not be just luck. In its early days, this planet may have had a very thick hydrogen atmosphere. After the outermost layer was stripped away, it still retained deeper heavy gases, such as carbon dioxide and water vapor, and when its surface gradually cooled down from a molten state, the atmosphere was no longer just drawn from the nebula. Instead, it began to be produced from within the planet itself. Deep volcanic and magma reactions released new water vapor from the planet itself, along with carbon dioxide. Together, they formed a thicker, more stable second-generation atmosphere. These molecules are not as easily blown away as hydrogen. Instead, they can persist for a long time. They create a new protective barrier for the entire planet. Simulations also show that this kind of geological and gas interaction establishes a redox balance within the planet. This is one of the most important chemical conditions for maintaining long-term habitability. More importantly, this planet is neither too close nor too far from its star. It happens to sit right on the edge of the radiation limit. It survived the star's most intense phase. In contrast, the innermost planet, Planet B, had a completely different fate. High-energy radiation almost hollowed it out from the inside. Its crust could never cool down. As soon as the volcano releases germ, the gases are immediately blown away. There is no way to retain any protective layer as a result. Starting from the same point in the same galaxy, they ended up with two completely different outcomes. One may be hiding water and managed to hold on to its atmosphere. It even had the basic conditions to nurture life. The other became a barren rock, silently cooling in the vacuum, destined to remain desolate. Simply put, this planet did not passively accept its fate. Instead, from within, it actively created a new environment for survival. These simulation studies have revealed a key conclusion. What determines a planet's fate is not random events that happen later, but the initial starting point, its distance, its original atmospheric composition, its geological conditions. These factors determine who survives and who is eliminated. Even if there is the slightest chance to recover later on, two conditions must be met. First, after the star's intense outburst phase, it must quickly enter a stable stage. Second, the planet itself must be able to retain heavier gases, such as carbon dioxide and water vapor, and establish even a weak but stable atmosphere. In a recent interview, one of the authors of the study, Totten, mentioned that star systems like TRAPPIST-1 actually represent a common challenge faced by an entire class of infrared star systems. These stars go through a long and turbulent adolescence, which is far more dangerous than the unstable phase our Sun went through, especially for planets that are too close. This year-long period of intense energy is almost fatal. Planets that originally had atmospheres were likely stripped bare before their crusts even had a chance to cool, completely emptied out, and those a bit farther away, barely surviving the star's high-energy phase, might end up due to changes in their orbits, and enter a cold new phase. Water freezes, gases fall silent. Eventually, everything becomes lifeless. This leads us to a seemingly startling conclusion. Too close, and you will be burned. Too far, and you will freeze. Only within that extremely narrow, on the razor's edge between life and death, a planet has just the slightest chance to become a cradle for life. Scientists have noticed a crucial phenomenon. As a red dwarf star gradually cools down, planets that were once bombarded and nearly destroyed may actually begin to recover. Little by little, simulation results show, as long as the initial conditions are not too bad, some planets, after the most extreme periods, can indeed, through chemical reactions, condense surface water vapor and slowly rebuild a self-sustaining atmosphere. Although they can't return to their original, complex environments, they may still form a stable, protective layer suitable for sustaining life. However, it is very difficult to verify these models. The brightness fluctuations of red dwarfs themselves often interfere with observations. This makes it hard for us, in the signals to distinguish features that truly come from the planets. This is especially true for planets with moderate temperatures. Their infrared signals are extremely faint, almost drowned out by the noise from the star itself. Scientists are planning to use the next generation of instruments to solve this problem. For example, a space telescope dedicated to finding Earth-like habitable planets, the Habitable Worlds Observatory. This project aims to use more precise instruments to truly separate those faint but important atmospheric signals, help us determine whether these planets have truly retained the basic elements for life. Toton pointed out in an interview that what really matters is not just whether a planet has an atmosphere, but more importantly, we need to figure out evolutionary paths under different initial conditions. What factors allow one planet to survive, while another is destined to be abandoned? His research offers a new analytical framework, specifically to study the process of loss and reconstruction. He reminds us that some planets may never have given up their chance at survival, but are simply waiting for the moment when their star quiets down. If this situation is common, so in the vast systems of red dwarf stars, life may have already been quietly evolving, and could have survived for billions, or even trillions of years, far exceeding the lifespan limit of our Sun. Every observation, every hypothesis tested, is part of our gradual process of understanding the boundaries of life's conditions, and these boundaries may not only exist as analogies on Earth, but also lie hidden on those seemingly insignificant, yet incredibly resilient planets. Up to this point, everything still appears to be just scientific exploration, but if we look up and see the bigger picture, we will realize, even if other life exists, they may have already learned one thing. Stay silent, which leads to another chilling hypothesis, the dark forest theory. Have you ever thought about this question? There are hundreds of billions of stars in the Milky Way. Around each star, there are several or even dozens of planets. We know there is more than just one or two habitable planets. But why is it that even today, we have not received any messages from aliens? One explanation is that they simply do not exist, but another explanation is even more chilling. They have always been there, it is just that they do not dare to speak at all. The dark forest hypothesis suggests that the universe is actually like a dark forest. Every civilization is like an armed hunter, stealthily moving through the woods. He does not know where the others are, nor does he know if they are hostile. The only logic for survival is to never reveal your own location, because once you make a sound, others might locate you first, and then destroy you. This is the most extreme security strategy. It is not for fighting wars, but to avoid being attacked. In such a universe, so-called communication, it is not the beginning of trust, but the prelude to extinction. Even if you want to coexist peacefully, the other side may not be willing to take that risk. This is the chain of suspicion. You do not know their intentions, and they do not know yours. So the default choice for everyone is to stay silent and hide. Stay silent. But if you really dare to broadcast your coordinates over the radio, trying to greet the universe, then you are like someone lighting a bonfire in a dark forest. Maybe you just want to keep warm, but to certain hunters, that is a signal to open fire. Under this assumption, the universe is not silent, but filled with the silent ones. It is not that they do not exist, but that they have all learned to keep quiet. If you think the dark forest sounds too pessimistic, or even like a concept made up by science fiction, then let us first take a look at reality, a core question that the scientific community has long raised. Where did they actually go? This was in 1950, when physicist Enrico Fermi, during lunch, brought up a simple question. At the time, they were discussing UFO phenomena. Fermi suddenly asked, "So where did they all go?" He was referring to if there really are a large number of alien civilizations in the universe, and the Milky Way is so much older than human civilization by far, then they should have developed long ago, and should be able to receive our radio waves, or even directly visit Earth. But the problem is, up until now, saw nothing. No clear signals detected, no spacecraft visits, no traces of interstellar colonization. The universe is like a clean, strangely blank sheet of paper. This is the famous Fermi paradox. Quantify this problem. In 1961, astronomer Drake proposed an equation in an attempt to calculate how many advanced civilizations might exist in the Milky Way. But this equation can only tell us a possibility. It can't explain why these possibilities have never become discoveries, at least so far. The Fermi paradox has only theoretical explanations and no observational support whatsoever. Physicist Adam Ferran once said, "The probability that Earth is the only civilization in the universe is about 1 in a trillion. In other words, believing that we are the only ones is actually the least scientific idea. So if they really do exist, why are they so quiet?" At this point, The dark forest hypothesis emerges as an extreme but reasonable explanation. It comes to the surface. It is not romantic, it is even a bit cold. It tells us they do not exist, they simply do not dare to make a sound. What makes this premise unsettling is that it explains the silence not only from a technological perspective but also from the standpoint of motivation and instinct, elevating concealment to a matter of survival. But this also raises a question. Are all civilizations equally afraid of being discovered? The technology of some alien civilizations has already far surpassed ours. Would they still worry about being exposed? Are they, like us, actively sending signals into the universe, trying to find others like themselves? The dark forest hypothesis offers a closed and chilling answer, but he also has blind spots. For example, he assumes that all civilizations are rational enough, and that survival is everyone's top priority, but he underestimates the differences. Civilizations may have emerged at different times, and their cultural values could be completely different. Just like in human society, some countries are open, some countries are conservative, while others are expansionist, some are introverted. Civilizations in the universe might also be diverse. Not everyone is necessarily afraid of exposure. Perhaps some civilizations are still in their infancy and do not understand the need to hide at all, while others have long since become powerful enough, unafraid of any threat. But why have we still not seen a single one dare to speak up? Perhaps it is because this universe really was not designed for peace. If we look at human history, maybe we can find a clue. In the 19th century, European countries massively colonized Africa. On the surface, it was about spreading civilization. In reality, it was resource plundering. That time, industrial development was rapid. Europe needed more minerals, energy, and land, and Africa happened to have all these resources, so expansion became a natural motive. The colonized suffered, colonizers benefit. This logic holds true on a cosmic scale as well. If resources are limited, while population or technology keeps growing, then conquest is not a choice, it is an instinct. Earth is studying exoplanets, planning Mars colonization and mining lunar resources. Do you think we are the only species doing this? What if there is another civilization searching for living space, just like we are? Then it is very likely they are after the same things as us. Water, atmosphere, habitable zones, exploitable geological resources. Once our targets overlap, it won't be about who says hello first. The question is, who fires first? This is the second layer of logic in the dark forest. Even if you do not want to attack, others will still think you might, so they will strike first. Once the chain of suspicion forms, there is no room left for trust. Even if you want to coexist peacefully, the other side might choose to eliminate you completely, simply because of uncertainty. In this kind of environment, the most dangerous action is not intrusion, but exposure. If there is anything most unsettling about the dark forest theory, it is the chain of suspicion behind it. What do you mean? He is not saying you are dangerous because you are hostile. He is saying the danger is that he does not know if you are hostile. I have no idea. That is dangerous enough. Imagine you are a civilization, you discover another unknown civilization. You do not know if they have the ability to attack you, or if they will become powerful in the future. If you hesitate, they might be hesitating too, and when neither side can see the other's cards, the safest choice is to strike first. This is what is called the chain of suspicion. I suspect you might attack me, so I have to guard against you first, and you suspect that I will guard against you, so you start preparing to strike first. This whole series of assumptions that things will get worse between us will eventually lead to the most irrational decision, to completely destroy the other side. Some scholars have pointed out this kind of suspicion chain usually only exists between civilizations with similar technological levels, because only when they understand each other will they be mutually wary. But if one civilization is far ahead of another, that kind of worry might not exist at all. It would just be total domination. This brings us to another dark concept. The technology explosion. Once a civilization makes a sudden leap forward, its very existence becomes a potential threat to others, because no one knows whether it might, overnight, suddenly become an uncontrollable superpower. At this point, the surrounding civilizations are likely to strike preemptively, even if it is just because they are afraid he will grow up too fast. But this also leads to a startling conclusion. Even if your intentions are good, as long as you are growing, others will fear you. So some benevolent civilizations end up in a deadlock. You do not attack others, but others are afraid you might attack them in the future. As a result, you were eliminated first, not because you made a mistake, but because you were too uncertain. There is a cruelest implication in the dark forest theory. Kindness is actually the most dangerous. If a civilization insists on not attacking first, not hiding, and not staying silent, then he is very likely to become the first to light a bonfire in the dark forest. And in this forest, Even a little light means exposing your position. If you believe that in the universe there are civilizations more advanced than ours, and that they are indeed much older than us, and think much further ahead, then they have most likely already accepted these ruthless rules. No speaking. No communication. No response. If you send out a signal, they might not receive it, but target you instead. So we return to one question. Does this mean that should Earth refrain from broadcasting any signals to the outside? According to the dark forest theory, the answer is that it is extremely dangerous. This viewpoint has actually gained support from quite a few scientists, including Stephen Hawking himself, who has also made it clear that we should not recklessly send our coordinates into the universe. We should not actively reveal our location. Since the mid-20th century, human enthusiasm for searching for extraterrestrial civilizations has soared. In 1974, we sent the famous Arecibo message to a globular star clustered 21,000 light-years away. Since then, humans have sent similar radio signals many times, as well as laser signals and image codes. We hope to make contact with the other end of the universe. But if you look at it another way, are these broadcasts really safe? We are actually like people in a dark forest, banging drums and shouting, "Aye," and we do not even know if there are hunters in the forest. What is more, we have not even figured out how vulnerable we are. We do not know who is listening, and we do not know what they have understood. We think we are sending a greeting, but to others, it might be a target lock. By that logic, the universe is not devoid of other civilizations. It is that every civilization, they have all learned the most ruthless survival strategy. It is better to say nothing at all than to reveal your location. In 2017, physicist Stephen Hawking put forward a disturbing idea. The radio signals humanity sends into the universe could very well be the beginning of a disaster. He believed that once an alien civilization, if we really receive these signals, the consequences could be like what happened in the 15th century when Native Americans encountered European colonizers. The disaster would not arise from hostility, but from an asymmetry in the level of civilization. That is why Hawking urged that humanity should immediately stop broadcasting signals into space. But some scientists have voiced different opinions. For example, Douglas Vaco, an astrobiologist at that institute, believes that if we choose silence out of fear, humanity could end up isolating itself. He points out that if advanced civilizations really exist, they would have had the chance to attack us long before Earth even developed, but they did not. So why should we worry about being heard only now? Some scientists also believe that different civilizations may have inherently different natures. Not all hunters will pull the trigger. Some may choose to hide themselves. Some might even choose to establish friendly and cooperative relations with Earth and work together to solve global challenges, such as climate and energy, and even survival itself, or even global catastrophes. Seth Baum from the Research Institute GCLI suggests that in the universe there may exist some non-aggressive, neutral civilizations who would neither harm us nor get too close to us. They just choose to stand by and watch, silently observing us, to see if we can survive this great selection. So should we send signals out or not? Should we just keep quiet? There is not a single answer. The dark forest is just one possibility. It is not the ultimate truth. It is true that maybe we have not found aliens, because they are all hiding. But it could also be that the universe is just too vast and too quiet, or that the chances of life appearing are simply extremely small.